talk about mezzanine boards. What are the biggest design considerations for this type of PCB? Reliability? Most definitely. Space utilization? Absolutely. Flexibility? 100%. Today's mezzanine boards, whether they're designed into a data center, car, or telecom system, or a long list of other applications where there are multiple connector sets on the same board, flexibility is tantamount. And one of the most important things to consider here is your contact interface. And folks, we're going to talk about some really cool advancements in the world of contact interfaces for mezzanine connectors today. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Jeremy Ellis from Amphenol Communications Solutions and I chat about the benefits of Amphenol's MEG-Array and M-Series connector solutions. We also investigate the tooling configurations available for these solutions and how Amphenol's ball and socket BGA interface can simplify board routing, eliminate press fit constraints on VIA, and provide excellent SI performance. And before we get started, don't forget to click that link. There you can find even more information about this topic from Amphenol Communications Solutions. Hi, Jeremy. Thank you so much for joining me.
Hi, thanks for having me.
Absolutely. Okay, so we're talking about the MEG array and M series connectors today. But Jeremy, before we talk about the benefits of these solutions, can you give us a brief overview of the different connectors that Amphenol Communication Solutions offers?
Sure. So within Amphenol Communications Solutions division, there is a high-speed product group. And within the high-speed product group, I'm part of the mezzanine business unit. So the mezzanine business unit has three primary products. We have compression products, we have what we call separable interface, which is two-piece connectors, and then we have flex assemblies. So the MEGArray and M series product that we're going to look at today falls within the two-piece products within our business unit.
Fantastic. Now, what kind of specific applications are we talking about here?
Yeah, so typically mezzanine products, another term in the industry for mezzanine products is board to board. And so it's typically going to be something like daughter cards on motherboards. We also will put these connectors on the flex assemblies for a wider array of applications. But typically, its data center is a common market space with CPUs and GPUs and memory modules. But then we are seeing customers, as more products need higher data rates and need larger connectors, we are seeing these products used now in automotive applications and things like satellites and artificial intelligence, but then just in basic robotics and industrial applications. We have some medical and military applications as well for these products.
Okay, so Jeremy, can you give us some details about the MEG array?
Yeah, so MEGArray is a legacy product for us. It's one of our top legacy products. It's been in the market for 2 decades, but it's still performing really well. It just happens to suit these types of applications well. So it's still in high volume today and readily available in distribution. MEGArray supports data rates up to 32 gigs, which is pretty good today. And because it's been around for some time, the good thing is it's tooled in a lot of configurations. So our smallest MEGArray connector is 81 contacts or positions, and then our largest is 528 pins or contacts. In mezzanine connectors, we're often looking at the stack height as well. And that's because the customer might have some other components on the board that they need to vary the distance of that daughter card on the motherboard. So that's why a mezzanine connector will come in different stack heights. So MEGArray is tooled from 3.5 millimeters up to 14 millimeters across all those different pin counts. It's a connector that's been in the marketplace, but it will last in the marketplace for 20 plus years. It's a very robust connector. For that reason, it's been qualified for situations like US car where it's in automotive applications today and it's in satellites today and things of that nature because it's very robust. Along with the different stack heights and pin counts, it's also available in a variety of plating options, which is something customers value. If you're doing a few mates and it's in a very controlled environment, you can use something like 15 micro inches of gold or GXT, which is a palladium nickel plating. If you're in a more high mate environment, you're in a test application, or you're in an uncontrolled environment, you're in a cell tower somewhere, then you would probably gravitate towards like a 50 micro inch gold, which is going to be a more robust plating for longer field life. And it's nice having all those options readily available that we don't have to do something custom for a customer. And I mentioned military earlier. We have leaded and lead-free product as well. And there's still certain military and like applications that might value a leaded product for certain reasons. And that would be the solder ball.
Okay, so Jeremy, can you explain the open pin field a bit more?
Sure. Yeah. No, I should touch on that. The MEGArray connector is what we call open pin field. And what that means is all of the contacts are identical, whether you're using them for high speed signaling, low speed signaling, power, or ground. A typical customer application, they're going to have some pins that they're going to want to do higher data rates for signaling. They're going to want to have some low speed signals for clocks and things of that nature. And then typically they're also going to run power through these connectors as a very common application. So the trade-off here is with MEGArray, you have an extremely flexible connector. With all the pins being identical, the customer at their PCB level will make a determination whether they want a pin to be high speed, low speed, or power, just in how they lay out their board. And so they've got great flexibility there. And the nice thing is the connector, even with this flexibility, still performs pretty well. We're getting over 2.5 amps per pin when we have less than 30 adjacent pins. We're still able to get to 32 gigabit data rates when we wire it out for high speed signaling. The alternative there will be M series, which we'll look at in a moment, which has a dedicated design that's very hyper focused on just highest data rates. So with the connector like MEGArray, you're not going to get the absolute highest data rate. You're not going to get the absolute highest power, but what you are going to get is a lot of flexibility built into the connector.
So, can you also give us an overview of the M series as well?
Yes. So we're talking about MEGArray and M series today because they're sister products. And so the M series connector is a next generation MEGArray connector, leveraging a lot of the best attributes of MEGArray and then building in some new learning, some new advancements that we've developed for this connector. So M series, it's going to look a lot like MEGArray, the contacts, the housing. The contact geometry is a dedicated differential pair design. So unlike MEGArray, it's not open pin field. There are dedicated pins for the high speed signaling, and then there are dedicated ground pins. Now, it is still, in a sense, open pin field in that some high speed connectors, all the ground pins are common together. They're all connected for signaling purposes. In this case, we have a dedicated ground pin in the design of the contact, but the pins are still isolated from each other. So we will have customers that will still, in a section of the connector, choose to use a ground pin for something like low speed signaling or power. But the design is there to allow MEGArray as a 32 gig connector. M series is up to 112 gig PAM4, which is a pretty high data rate in the industry, which is going to be something that's going to support something like, advanced computing or, AI applications, things of that nature on GPUs. But that said, it's still like MEGArray, a very robust connector. So we do have customers that are choosing the M series connector, not only for the data rate, but because of maybe it happens to be tooled in a pin count that's good for them, a stack height that's good for them, or it might just have certain other features that they might gravitate towards for M series over MEGArray outside of just data rate. So Again, like MEGArray, it's tooled in a variety of stack heights because we are supporting, customer applications where they need that variety. So 4 millimeters on the low end, up to 11 millimeters at the tallest stack height tooled today. The design will go up to 14 or 15 millimeters in the future if a customer should need that. In the case of M series, typically because it's a diff pair connector, we're looking at the number of diff pairs in the connectors or the number of columns. And when we say a column here, each row or column has 4 diff pair within the pin count. So a customer will typically come to me and say, I need this many differential pair being a pair of contacts designed for high-speed signaling, and we'll work with them for the appropriate column count, size of the connector to get the number of pins they need for high-speed signaling, low-speed signaling, and power. In our industry, in mezzanine connectors and backplane connectors, typically the wipe's important. A millimeter of wipe is pretty good for a low-profile connector. And wipe is when the beams touch each other. So we've got two halves, a male and a female, a plug and a receptacle. As they mate, they're going to make first contact, and then they're going to extend 1 millimeter in what we call wipe, which is just giving reliability to the mating interface to ensure that even if it was unmated a little bit, you still have good electrical connection. We're 1.6 millimeters column to column. And the reason for that is for signaling purposes, and it also gives a routing channel that as a customer is laying out their PCB, they've got an area to route those pins out to their PCB. M series leverages MEGArray, and it does that in the contact interface design, but most importantly, it does it at the BGA level, which is the solder sphere. It's how the connector connects to the PCB, and that's a very important piece of technology for us. We've taken MEGArray and we've taken the opportunity to build in some additional features for various reasons. Sometimes it's for signaling. We added a little bit of wipe. One of the features we built in was just adding this protective layer on the receptacle. So in the design of these connectors, we have a plug and a receptacle, and based on our contact design, the plug is a very robust blade. It's thick, it's flat, and it's unlikely to be damaged even if a foreign object was to fall into the Pinfield. The receptacle half, just the design of the contact has always inherently been just a little bit more fragile. And so we took an opportunity that's not in MEGArray, and when we were redesigning this connector, we enclosed the contacts recessed below protective plastic within the housing. And this is great in the field in an unmated state. The customer is handling the connector, the customer is processing the connector. Maybe it's a test application, any application really. And really what this is just preventing is a foreign object, whether that be a finger or a tool, from entering the contact area and potentially damaging the connector. So it's just a nice little feature to give a little more assurance to the customer.
Fantastic. Now, Jeremy, what kind of tooled configurations are available for this solution?
So for M series, it's a relatively newer connector. And so we're tooling it first just where we see good potential in the marketplace, and then we're tooling it as customers come to us and have a need. So MEGArray is tooled in over 80 configurations today, almost any configuration a customer might need. M series is relatively fewer today, but we are adding to it monthly and quarterly. So we'll highlight that on the smallest side, the M series connector is tooled in a 4-pair, 12-column configuration, and that's at 4 millimeters, at 5 millimeters, and at 11 millimeters mated. So a 4-pair, 12-column provides a customer with 48 differential pair, or that would be 156 pins. And then on the opposite side, the largest tooled configuration, 4-pair, 40-column for 160 differential pair and 520 pins. So we're continuing to build out this product family. It is in high volume today. It is available in distribution channels today, and we're continuing to add to the tooled configurations. And I should highlight that when we tooled this product family, we were looking at it very much like a product family. and we built the tooling to give us the ability to do changeover in the tooling. And typically for a mezzanine connector, it's the housing mold that you're looking at as the defining feature that you need to tool to bring a new configuration to market. So in our housing mold tooling, we built family tools, flexible tools to make changeover tooling easier, lower cost, and lower lead time. So it gives us the ability to work with customers in a more advantageous way for both us and the customer to bring a new configuration to market if there's a need at the customer level that isn't already met by an already tooled configuration.
So, Jeremy, contact interfaces are a crucial design concern to keep in mind here, right? So, what does that look like for these solutions?
Yeah, no, that's great. I would definitely like to spend a little bit more time on this because, yes, for any high speed connector, the contact design is first and foremost. It provides the data rates that the customers require in their applications and then reliability. So with MEGArray, we have a very proven contact design. It's been in the market in very high volume in a multitude of applications for many years. And we leverage this contact design in M series. In M series, we adjust certain critical dimensions to get us to that higher data rate, but the basic design is the same. And the design is two different contact designs. The male half we call the plug, the female half we call the receptacle. The plug is a flat blade. The advantage there is it's very robust. The receptacle is a dual beam contact design, and you can see it in the imagery. The great feature of the dual beam receptacle is it's mating on both halves of the plug, which is a little unique compared to some other like connectors in the industry. With the dual beam receptacle mating on both halves of the plug blade, we have normal force offsetting first, which is nice, but we have normal force on that plug blade on both sides. And what that does for us in a situation where there's shock and vibration, you want to ensure the integrity of the signaling. And so this particular contact design, if you were mating on just one half and there's shock and vibration, it would be more likely the contact might, even if it's for a microsecond, it can create issues at the customer level. But with this contact design, mating on both halves, you've got, first off, redundancy. You've got 2 points of contact, which the industry looks for. But with that offsetting normal force, if one contact would theoretically start to become less engaged, you're becoming more engaged on the mating half. And what that does for us is it makes this an ideal connector for those automotive applications where you certainly have shock and vibration, and even applications like solid state hard drives. Surprisingly, shock and vibration is very important. And not only do we have the historical reference of the contact, but even recently for applications like self-driving cars, we've done a lot of additional testing on this contact against very high shock and vibration requirements and demonstrated the performance of the contact.
So, can we also talk a bit about the ball and socket BGA aspect as well?
Ball and socket is a design feature for starting with MEGArray and now extended to M series that we really like to highlight. It's a patented design. And what it is, we form what we call the pocket, a recess for every solder sphere within the housing. And with the IP around that, other connectors are not able to offer that. Now, what a ball and pocket does for us is twofold. First off, when you at the factory place the solder sphere and process the connector, when we build these connectors, we start with a housing, we stitch the contact into the housing, and then at the factory, we place the solder spheres and attach the solder spheres to the housing, ship it to the customer for them to process to their PCBs. With a ball and pocket design, the solder spheres are extremely well controlled. We're able to place them, they reside within that pocket, we reflow them onto the contact within that pocket. We 100% inspect every connector, every solder sphere within every connector with AOI, with automated laser inspection equipment. for true position and height of that solder sphere. And if you just had the solder sphere, if you could picture it without a pocket, just residing on a contact in the air, as you reflow it, both at the factory side, but then at the customer side, it's more likely to want to slump to one side. And now the true position, the location of that solder sphere is not as advantageous. But now it becomes even more impressive and helpful to the customer. When they process it to their PCB, you have a close, intimate connection with the housing to the solder sphere to the PCB. And through surface tension, just through physics, the solder sphere will want to self-adjust, self-center to the PCB pad. And in manufacturing, because of the importance in the industry, they very tightly control the location of a PCB pad for their boards. With the housing able to self-center to the PCB via the ball and pocket in the solder sphere, you know you have really good true position, really good location of the entire connector, the entire housing. And that's always a good thing, but it becomes really, really important and really, really helpful when you have multiple connectors on a single board, which is becoming more and more common across all applications. We've seen customers, very common to have two housings on a single board, becoming more common to have three connectors on a single board. And we've seen 7, 11, and more connectors on a single board. And if you have a single connector on a PCB and you're bringing the mating half, if one of them's slightly askew, it's not as big an issue, because if there's no mechanical architecture, if there's no standoffs holding them apart, the board could adjust a little bit. But the moment you have two connector sets on a board or three connector sets on a board, if one of them would be off even microfractions of an inch, less than a millimeter, you'd have an issue, because now your contacts aren't aligned, your housing's not aligned, you're going to have mechanical interference, you're potentially going to damage a pin. And we don't see that with these connectors, which is just really great. So customers can have the 2, the 3, the 7 connectors on a single PCB. We show an image here where we have 4, 5, 6, 7, 8, 9, 10, and we could put 12 connectors on a board. And we've mated these by hand. We've force offset them a little bit, and there's no issue, because every connector, every pin, every solder sphere is exactly where it should be on the board for advantageous mating, which is really great.
All right. Well, Jeremy, I think that's all I have time for today. Thank you so much for joining me.
Yeah, no, I appreciate your time and having a chance to talk about these products a little bit with you today.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.